Microscopes that do more than just magnify hold promise for improving outcomes in the operating room. It's not brain surgery, it's light matters. This is Light Matters for November 4th, 2015. I'm your host, James Lowe. On this episode, we're looking at advances in microscopy. Over the past month, we've heard from a number of research groups doing exciting work in the field and looking for ways to make microscopy even more useful and life-saving. A number of startups have also introduced unique technologies in recent weeks. Echo Laboratories of San Diego teamed up with the Minnesota rapid manufacturing firm Proto Labs to introduce a combination upright and inverted microscope. Proto Labs, meanwhile, has just gotten into laser additive manufacturing with the acquisition of Alphaform from Germany. Also in Germany, a startup called Luxendo will use 6 million euros in venture capital to develop instruments that can image live cells over extended periods using selective plane illumination microscopy, or SPIM. Luxendo grew out of the European Molecular Biology Laboratory, where developers in 2012 used the technique to image cell division in a fruit fly embryo. Meanwhile, a team at the Genelia Research Campus in Virginia has developed a light sheet microscope it says beats conventional models in terms of spatial and temporal resolution, as well as the size of the organisms it can observe. IsoView has been used to visualize cell-by-cell activity throughout the nervous system of an entire living fruit fly larva, an organism that has more than 10,000 neurons and is about 50 times larger than the roundworm C. elegans, which until now was the only animal whose complete nervous system had been imaged at the single-cell level. Still ahead, we'll see how advanced microscopy techniques are finding their way into the operating room. But first, Photonics spectra editor Justine Murphy tells us about some new takes on fluorescence imaging.
Emitting at the far red end of the visible light spectrum, a DNA stain could enable imaging of live cells over the course of a day or more. Existing fluorescent stains that light up DNA within cells are toxic, or they require blue or UV light that can damage cells, and they don't work with super-resolution microscopy techniques. The far red stain, on the other hand, is super-resolution compatible, non-toxic, and activates when it comes in contact with DNA, according to its developers at the Swiss Federal Institute of Technology in Lausanne. Light emitted by the new stain is easily distinguished from any background fluorescence of living cells. The researchers are preparing to commercialize the stain through the spin-off company Spirochrome. Meanwhile, in Massachusetts, the Harvard University spin-off UltraView is commercializing DNA-based fluorescent labels that it says will provide standard microscopes with super-resolution imaging capabilities. One actual super-resolution technique, stimulated emission depletion, or STED microscopy, subjects dyes to high-intensity light that can quickly wear them down. But now, researchers at Nagoya University in Japan have developed a dye that keeps fluorescing strongly after more than 50 STED sessions, where others give out after just 5. And at the University of Illinois, researchers have produced quantum dots that emit light with equal brightness regardless of their color. This could help microscopists differentiate more accurately between tissue types and gather quantitative data about tissue concentrations.
Thanks, Justine. So far, we've been talking about microscopes used in the laboratory, but we're beginning to see them in other contexts too. Several research groups are working on smartphone add-ons that can bring diagnostic tools to poor and remote areas. You can learn more about that at photonics.com/bioconference, where we have an interview with bioimaging pioneer Idwin Ozcan and presentations on a variety of other innovative techniques. Another place where we may begin to see more microscopes is the operating room. Surgical microscopes used for magnification have been around for some time, but now two groups are refining some more advanced imaging capabilities for this setting. One group is using a stimulated Raman scattering microscope to provide rapid pathology results during brain surgery. Dr. Daniel Oringer of the University of Michigan explains.
It generates microscopic images, but it doesn't require any fixation, processing, dyeing of the tissues, so it allows us to do this in real time. Without any delay in tissue processing. And this ability to differentiate on a microscopic scale between tumor and normal brain allows us to provide more accurate surgical results to the patient.
The researchers have used their system to assess tissue samples from 60 patients since June. They said that someday the Raman microscope could become a more affordable and practical intraoperative imaging tool than existing systems like MRI. Meanwhile, a device developed at the University of Arizona superimposes near-infrared imagery onto the field of view of surgical stereo microscopes already used in neurosurgery and other procedures. This allows visualization of subsurface details such as blood flow, as well as cancerous tissue. It can also reveal beams used in laser surgery, which otherwise would be invisible. While near-infrared fluorescence has been used in surgery for about a decade, previous systems could only toggle between NIR and visible imagery, rather than combine them. You can find more about all of today's stories at Photonics.com.
The November issue of Photonics Spectra will hit mailboxes next week, filled with the latest business, technology, and research news. We hear from industry experts about image sensor technology for enhancing astronomy research, techniques for overcoming challenges with small beam mode field diameter measurement, optimization of coherent optical modulation analyzer acquisition systems, commercial thin-film solar technology, and ways interferometry can more effectively measure optical system performance. Get all this and our new 2015 laser reference chart in the November issue. Those who haven't already can subscribe for free at photonics.com/subscribe.
And that's it for this edition of Light Matters. Thanks for watching.